Good evening, everyone. Today we will see chemical kinetics. Now, first, let us see what is chemical kinetics. It is the branch of physical chemistry which deals with the rates of chemical reaction and the mechanism by which they occur. Now, we all know that there are certain reactions which are slow and some are fast. For example, lightning of matchstick is a fast reaction. Fire crackers catches fire, it's a fast reaction. And there are certain slow reaction in day-to-day life, like curdling of milk. It at least take 3 to 4 hours to form curd from the milk. Similarly, rusting of iron is a slow reaction. So the different reactions have got different speeds. Now, why one must study chemical kinetics? So, for the industrial processes, to optimize the reaction so as to get the maximum yield by minimizing the production cost and by optimizing the different parameters which is affecting the rates of reactions, we can increase the yield of the reaction. So, chemical kinetics is very much importance for industrial processes. Similarly, it plays a very important role in drug designing. So it understands how quickly medications react in the body. Now we all know that when doctors prescribe some medicines, they tell us that you have to take this tablet as it is. And for small children, we convert it into powder form. Okay, so there are certain medicines which cannot be converted into powder form. They has to be taken as it is, because that will affect the reaction time. So how much time it will react with the body. So to design the drug designing, chemical kinetics plays a very important role, and there are some other applications also. Now, what is rate of reaction? The rate of reaction is the change in the concentration of the product or the reactant. Okay, so there are two things in any chemical reaction: reactant and product. So when the reaction proceeds, the concentration of the reactant decreases and that of the product increases. So this is change, either decrease or increase, both are change. So rate of reaction is the change in the concentration of the reactant and the product, of course with respect to time. Therefore it is given by change. This delta indicates change. So change in the square bracket indicates the concentration. So delta T is the time with respect to time. And why we have written negative in front of the reactant? Because the reactant concentration will decrease with respect to time, and in front of the product we have written positive sign, which indicates that the concentration of the product will increase with respect to time. Now let us skip this slide. Now there are various factors which affect the reaction rate. One is temperature, concentration, catalyst, and other factors also. First, let us see concentration. Now higher the concentration, in most of the cases, more the concentration, more will be the reaction rate. So this is because of the molecular collisions. As the temperature increases, we have already studied that kinetic energy is directly proportional to the absolute temperature. So when temperature increases, the kinetic energy of the molecules increases, which leads to more collision, which leads to faster product formation. Okay, so the reaction rate increases. Similarly, concentration. So more the more number of molecules will be present in a given space, more will be the collisions and the reaction rate will increase. Similarly, catalyst. So catalyst is a substance which speed up the reaction, but it doesn't participate in the reaction. Okay, its form may change. If the catalyst is present in the solid state, after the reaction it may convert it into liquid or any other state, but it will not participate in the reaction. Then and the temperature, of course, for every 10-degree rise in temperature, the reaction rate gets double. Then this we have already seen. Then there are certain other factors like solvent and the light. So in fact some reactions are there which are known as photochemical reactions, which are affected by the light. For example, photosynthesis. These are the different state expressions for the rate law. So rate is given by, rate of the reaction is given by the rate constant multiplied by concentration of the reactant raised to the power their stoichiometric coefficient. Okay, so this small m and n indicates the reaction order. Small m indicates the reaction order with respect to the reactant A, and small n indicates the reaction order with respect to B. So the overall order will be m plus n. Then integrated rate law. So the first there are different rate laws, zero order, second order, first order, second order. So for today's class we will stop here. Thank you.